We're going to have a look at factorising quadratics, a topic you should be familiar with from your GCSE. Let's start off with a nice simple example. We want to split this into two linear factors, so linear meaning it only has an x, not a quadratic, no x squared, which will help us solve it. In order to do that, we need to think of two numbers which multiply to give 12 and which add to give 7. Thinking through the factors of 12, you've got 12 and 1, doesn't add to give 7. 3 and 4, that does add to give 7, so we're done. We could also check 6 and 2, doesn't add to give 7. There will only be one way of doing this. Now we've got it factorised, this becomes a lot easier to solve. Because we know when we multiply these two numbers, whatever they are, together, we will get 0. That tells us that one of these factors must itself be 0. There is no other way to get 0 by multiplication than if one of them was 0 itself. For example, if you had 7 times 0, that is still going to be 0. In fact, anything multiplied by 0 will still give you 0. However, it doesn't matter how small a number you multiply by a non-zero number. Multiplied by, say, 2. You are still going to get some non-zero answer out. The only way you can get 0 is if one of your factors was 0 originally. So, using that bit of information, we can look at this and say, well, we know that either x plus 3 is 0, or alternatively, x plus 4 was 0, meaning that x is either minus 3 or x is minus 4. There is no way of telling which one of those solutions we want. They are both valid solutions. X could either be minus 3 or 4. Having a look at another one which is slightly more complex. Let's go for minus 4x, and then we'll have a minus 21 here. Now we need, something fell over. Now we need factors of negative 21 which add up to negative 4. Or alternatively, another way to think of this, numbers which have a difference of 4, as we know that one of them must be positive and one must be negative in order to give us a product which is itself negative. Thinking through factors of 21, the only options are 21 and 1, clearly not going to give us 4, or 7 and 3. Those numbers will work. Now we know that when we add these two together, these two linear terms together, we should get minus 4. That tells us that 7 must be the negative number and 3 must be the positive, as otherwise when I did minus 7 times x and 3 times x, that does give me negative 4x's overall. If I swapped the signs around, I would have had positive 7x, negative 3x, that would have added together to positive 4. So the only difference would be if you had a positive 4 there, those signs would be switched. Okay, so now that we've got that, that tells us that x is either negative 3, remember we set that factor equal to 0 and solve, or x is positive 7. We've got our two solutions.